Today we'll be proving this very interesting formula related to analytic number theory. So, in order to prove this, the first thing we want to notice is that a very important fact, which is that the floor of square root of x, this is this function counts the number of perfect squares less or equal than x. Perfect squares less or equal than x. And this can also be written as the sum as n is less or equal than x of s of n. And s of n right over here is, its name is the indicator function, the indicator square function. What does it do is that s of n takes when n goes through all the values less or equal than x, it takes the value 1 when n is a perfect square and takes the value 0 when n is not a perfect square. So basically, this function s of n can be defined as 0, 1, if n is some c square, and here if n is not a perfect square, right? So if we consider our left-hand side, which is the sum as n is less or equal than x of the floor of square root of x over n. Basically, we said that the floor of square root of x is equal to the sum as n is less or equal than x of s of n. Hence, this is equal to the sum as n is less or equal than x of the sum as n is less or equal than x of the floor, no, of s of x over n. And this is if you're familiar with the Dirichlet sums, this is a very familiar sum, and this can be rewritten as the sum as n is less or equal than x of s of n times the floor of x over n. Right. And this sum has a value that is different from 0 only when n is a perfect square. Because if n is not a perfect square, then s of n is just 0, and the entire product becomes 0. So we can rewrite this. So basically the sum, instead of going through all n's, it goes through all perfect squares less or equal than x of s of m squared, which is 1. So of the floor of x over m squared. This is equal to the sum m is less or equal than square root of x of the floor of x over m squared, which is exactly what we wanted to prove. So I hope you guys enjoyed this video. Please do not forget to subscribe to my channel and like this video for more content.